Well, I guess we'll go ahead and get started. For those of you that don't know me, I'm Wes McGee, Professor of Architecture here. It's my pleasure to introduce Farzin Lotfi-Jam. He's an Assistant Professor of Architecture at Cornell University, where he develops the Real-Time Urbanism Lab. The lab focuses on the use of spatial media and technologies in urban research, particularly the impact of digitalization and real-time data on urban environments. He also leads Farzin Farzin, a design studio operating at the intersection of architecture, computation, and media. His work is in the collection of the Centre Pompidou, the Sharjah Art Foundation, and he was a recipient of the 2022 Architecture League of New York Prize, as well as recent grants supporting his work, including the Alexander S. Onassis Foundation and the Graham Foundation. His work has been exhibited at the Storefront for Art and Architecture, Maxi, the Venice Architecture Biennale, and pretty much every other biennale you can name. His publications include the co-authored book, Modern Management Methods, Architecture, Historical Value, and the Electromagnetic Image. He's currently working on a new book titled Real-Time Computing, Southwest Asian and North American Urbanism, 1858 to now, which traces how real-time technologies from the colonial telegraph to the digital twin operate as tools of imperial control which shape urban life. Many of us got to know Farzin when he was a fellow at the Taubman College back in 2014, producing some very large and very hairy 3D prints installed in what is now the TVLab. Since those early days, his work has gone on to develop what I consider an incredible creativity in its approach to very serious topics in our field. Please join me in welcoming Farzin back to the college.
Hello, everybody. That's working. That feels good. Thank you so much, Wes, for that beautiful introduction. It's so nice to be back amongst friends and colleagues and an institution that has, I think, shaped my intellectual journey like none other. So it's really an honor and a privilege. Thank you so much. My talk today is titled Real-Time Urbanism, the Architecture of Packets, Pixels, and Neurons. And I'm going to get into that in a second. But just to give you, to give you a little bit of an overview of my interests and a little bit about the sort of form my research takes, my work examines how contemporary digital technologies and different forms of modeling from AI systems to real-time systems reshaping architecture, cities, and the ways we govern populations and environments. I approach this through media history and design expertise. Is that still working okay? I got rid of that. Perfect. Critically examining how algorithms, archives, and simulations, yeah, that's a good laugh, impacts the built environment. Please laugh more. I like that energy. By the way, I did this triangle in PowerPoint. I was pretty proud of it. So then I just kept going. And so through my practice, Farzin Farzin, and the Real-Time Urbanism Lab and my scholarly practice, authored under my own name, Farzin Lotfi-Jam, I try to bridge computational innovation with critical theory to address new technologies, social impacts. In some sense, I'm sort of operating across these three different channels, and I try to both study and develop technology and to use design to make my findings and inventions impactful to broad audiences. So I'm doing some, I was kind of joking with everyone, this talk might go for 2 hours because coming back to Taubman after so long, I just couldn't help myself. So I'm going to do something I haven't done before, which is to kind of show 3 different ways that I work on the same topic. From this idea of real-time urbanism, how it's unfolding in my scholarly practice through my current book project, how it's informing my design projects, and the kind of technology we're making around it in the lab. So, to give you a little bit of trailer for the talk to come, my independent and collaborative practice, Farzin Farzin, has been, for I think over a decade and a half now, has been interested in the longer history and trying to expand our understanding of architecture's complex relationship to technology. You'll see some Taubman people in this video. My practice uses data analysis, critical form making, and new media to investigate the history of computational paradigms in the city and their origins in colonial governmentality. I then traced the residues of these colonial logics in contemporary technologies. While I draw upon understudied yet influential moments in the evolution of computation, I apply these to the most contemporary of design practices, working with AI models in virtual reality, leveraging advanced fabrication, and new spatial media in an interdisciplinary form of something that I term critical computational architecture. Actually, this project here, which is called Doxiates Informational Modernism, that looks at the history of the Doxiates Associates Computer Center and was first shown in Athens and then in Venice at the Biennale. It has a whole section on the work of Doxiates in Ann Arbor and in Detroit and Michigan, and we're currently in conversation with the Hellenic Museum of Detroit to see if we can bring this exhibition to Detroit. So fingers crossed, we're in the fundraising phase. The Real-Time Urbanism Lab is something that I funded in 2022 when I first went to Cornell. And in a sense, my scholarly work and my design practice have built a critical framing through historical methods to try to understand how technology is shaping cities. And in the lab, I try to be projective and do applied research and actually think about the future of cities, not just their parts. And so these critical historical and experiment methods are shaping the way we're trying to work with different diverse stakeholders, from planners to scientists to activists and community members. Our expertise merges 3D modeling, real-time technologies like gaming engines, simulations, with critical research and the invention of new technologies around generative models and different AI systems. So key projects include augmented reality apps for housing rights activists seen here in Barcelona, a study of global digital twins governance. We've also developed different agent-based modeling software, one for a community-focused digital twin that's funded by US Department of the Interior grant, and a research track with an NSF Crisis Award funding targeting climate challenges in New York. Additionally, we're partnering with different people through a researcher in Singapore, a researcher in Bangkok, and we're basically developing a larger conversation around what we're calling ethical urban modeling that informed a comments piece that we published in the new Nature Cities publication journal that's just started up. And so these diverse collaborations with professionals from various fields showcase our commitment to using innovative new tools to try to address pressing urban challenges. Okay, my current book project, which actually has a bunch of different names, I'm going to workshop some with you. And one of them, not the one that Wes said, is Real-Time Urbanism, the Imperial Architecture of Now. And this book examines digital technology's role in modern urbanism and imperialism. It reinterprets this term, real-time, which is commonly associated with instantaneous computing, as a mechanism of imperial dominance influencing spatial and temporal realms. So the book traces computation's origins beyond our conventional mid-20th century geopolitical sort of narrative that we have to longer histories that involve 19th century colonial endeavors, focusing on two geographies that are connected together, Southwest Asia and North America, and looking at how histories of conflict, histories of violence, histories of information extraction, classification, and territorial management through technologies like the telegraph and later through real-time systems have really shaped this dynamic. So that, if you get nothing else, that's it. You've got it all. That's the three channels and this project operating across those three. But now we're going to sort of go a little bit deeper. So I want to take a step back and now briefly frame how I'm using this term real-time and what I think it has to do with packets, pixels, and neurons. And so for me, real-time isn't just a technical term. It is, I believe, the most consequential force of technological development that's facing our planet, with direct implications for architecture, especially in how space, time, and perception are ordered. Has anyone ordered a Domino's pizza lately? Come on, no shame. You're nodding, put it up. Thank you, Ali. Did you use the app feature that lets you track your pizza's journey in real time? I was stuck somewhere and I got a pizza and I'm just like watching my pizza come to me, and then I was here and the pizza shop was here and it went like this, and then it went like this and then finally came here, but I watched that for like an hour. So it didn't, basically your pizza takes the same amount of lateness to arrive, but you get to enjoy that in real time. What about an Amazon package? Has anyone ordered something on Amazon? Of course you have. Did you get an Uber ride? Did you go on a Zoom meeting? Have you watched the SpaceX launch, a Twitch stream? Did you swipe into this building late at night to get in with a key card? Have you walked downtown and noticed sensors mounted on poles, recording environmental data, pedestrian movement, or vehicle flows? Maybe you have smart devices at your home and you can watch your doorbell feed from your phone right this moment, and that's what you're doing, and that's your jam, and like no judgment, I do that too. These are all different expressions of real-time systems. This collapsing of monitoring, modeling, broadcasting, and managing. They range from the banal and ubiquitous to the spectacular and exceptional. They reflect a broader historical force, the drive to observe and intervene across distance, both spatial and temporal in real time. From the saturation of urban environments with sensors like the ones shown here, to the growing expectation that everything should be remotely tracked or controlled, cities, homes, and institutions have become sites of constant observation. And we, in turn, have grown accustomed to watching ordinary urban events like a pizza moving from a shop to a door as though they were significant occurrences demanding real-time visibility. Let's consider a kind of a banal moment. Someone sits at a computer and presses a key. And these are some analytical drawings I've been making to try to trace the temporal and spatial expression of real time. So someone presses a key at their computer. This single action triggers 3 concurrent processes at different speeds and scales. The first sends a data packet through global telecommunications infrastructure, crossing networks and returning from an intercontinental server in about 20 milliseconds. Another way to show this is in this like more linear way. So the same event. The second pushes a pixel to the screen through peripheral system and display devices in roughly 100 milliseconds. The third stimulates neurons in the user's brain in response to the visual chain processed in as little as 13 milliseconds. This moment reveals the layered temporality of real-time systems. It's not just about the speed, it's also about how real-time manages this planetary infrastructure and the types of perceptual responses and computational coordination that entails, where biological systems like your eyeball is connected to your GPU for less than 100 milliseconds. In a sense, I'm arguing through the book that real-time is a type of ephemeral architecture that connects all of these physical objects together in direct informational and physical pathways for a certain fleeting numbers of seconds at a time. And that real-time has a kind of a history and that it has a political and spatial expression. That same occurrence, imagine now, that as you're sitting within that network, you're also being tracked and captured through a whole bunch of other systems. This is actually the 2019 Fortnite World Cup at the Arthur Ashe Stadium in Queens, New York. Has anyone seen does anyone watch tennis? Where the Grand Slam final is? This is that stadium. So in 2019, they sort of suspended this thing called the Jumbotron in there, and 100, they were all boys, competed for like millions of dollars of funding. And so I'm kind of interested in these new types of urban typologies like this event that are emerging through a kind of a form of real-time immersion. And so in this space, the traditional sort of typology of the stadium is actually inverted. The stadium was optimized for, a whole bunch of people sitting around watching a single event all together. Now we have 100 people in 100 different events, with network events, with broadcast events, and they're being captured through a system of computational, televisual, real times, and broadcast to all sorts of different devices at once. So the audience in there is all experiencing a different version of this experience at the same time. So this sort of mediation of architecture and event through real-time systems is something that I'm interested in. And that's the sort of trajectory. So I'm kind of making these spatial and trajectory diagrams in the book to try to understand this more. And so with this framing in place, I want to shift from how real-time operates at the level of infrastructure to how it functions at the level of representation, and how it really, the sort of targets and subjects of monitoring, modeling, and management by all these systems is various environments, populations, and individual humans. And it kind of leads to my central research question that's really focusing on what role digital technologies, predictive models, generative systems are all playing in shaping contemporary urban life, and how do they extend long-standing struggles over territory, governance, and populations. These systems, whether AI, algorithms, sensors, networks, digital twins, metaverses, simulation platforms, all build on a similar sort of convergence of computation with populations and cities, and they all have a history and a context in which they're invented that informs their capabilities and effects, and this is what I'm interested in. They encode political, economic, and cultural assumptions about how cities and populations should function. And so through my design work, I try to examine how military and imperial technologies of computation have become embedded in the logics of urban governance and how they might be resisted or reconfigured. I'm also interested in the architecture of real-time media, what physical systems must exist to produce something as banal as a Domino's pizza rendered as a moving dot on a map, or in the case of this project you're seeing here, a detected image of a migrant approaching the EU border. So in some sense, and actually Meredith Miller gave me this framing, what is the back-end architecture of the front-end real-time image? So behind this image is an entire sort of, large infrastructural system. And so to return to that Domino's example, the Domino's pizza image depends on a chain of material infrastructures. A GPS-enabled smartphone in the delivery driver's hand, vehicle tracking sensors, cellular towers and antenna arrays, Wi-Fi routers, fiber optic cables, cloud servers in data centers, load balancers, edge computing hardware, and also the user's screen where the map is rendered. And each of these moments, in each of these moments, movement is captured, transmitted, processed, and displayed through a vast network of hardware, software, and urban infrastructure. And these are all built to sustain the illusion of seamless real-time visibility. But what we choose to monitor in real time and what is presented as convenience, necessity, or urban efficiency reveals the subjects and objects of real-time capture, from predictive policing like gunshot detection systems in urban neighborhoods, to resources with concepts like digital oil fields, to electronic battlefields, the sort of origin of all the real-time monitoring and systems we have, to borders where real-time systems, and throughout all these examples that I'm looking at in the book, real-time systems normalize surveillance, they turn marginal urban communities into passive data subjects, and they extract new forms of value from urban life. They also produce new urban models like digital twins shown here, and they create new forms of tracking different behaviors from humans, whether it's their faces or different versions of the poses and gaits. What we don't monitor in real time also matters. Environmental pollution, fraud, political corruption, and the activities of the powerful often remain outside real-time scrutiny. Famously, Elon Musk killed the Twitter bot that was real-time monitoring his private jet using open source data, which at the time he said all real-time bots were acceptable, within that sort of, free speech, open sort of platforms rhetoric that he was first sort of professing. And so all of these different examples where Tesla workers can monitor your private car in real time, but the public can't use open source data to monitor Elon Musk in real time, demonstrate how real-time visibility is unevenly distributed and strategically controlled. Okay. So I want to take a step back now and look at 3 examples to tease out some of these problematics that I've been explaining. And they're shown here. So in these 3 examples, a human is represented in various different ways in real time. A human is a particle in a linear flow, a human is a skinned mesh in a complex flock, and a human is a stroke width in a network of lines. These are not metaphors, they are computational models of individual identity in 3 recentish real-time simulations of urban movement. The first in the top left is a New York Times article, the next is a PlayStation video game, and the third is a new commercial urban planning tool. What do these examples from journalism, gaming, and urban governance tell us about how human behavior is rendered computable? What do they reveal about how cities are imagined? Each example visualizes bodies in motion, but in different ways and to different degrees of real time. The first simulation appears in the New York Times, and it's an interactive story titled How the Virus Got Out. It visualizes the spread of COVID-19 from the Wuhan region across the entire globe. The page runs live in a browser-based simulation of hundreds of millions of people's movements rendered as particle flows derived from cell phone data. The entire piece is written in JavaScript with over 60,000 lines of code translating pre-processed geolocation datasets into dynamic visualizations. As the user scrolls, new layers of simulation animate in response. Much of the code actually is dedicated not to data analysis or journalism, but to ensuring high-performance runtime responsiveness. That is, optimizing these visuals to appear live in the browser rather than rendering them as pre-recorded video. So I'm curious, like, why does this sort of illusion of liveness matter? Like, why do we have to see these as computational models running there rather than as animations? Because they're not interactive, they're not really doing a lot of work. And so clearly there's some type of authority that these visualizations produce, given that they're kind of running as, scientific, programmatic sort of data visualizations. And there's also some type of responsive relationship that's built up with the user, that every time they scroll, it initiates a different type of response that releases a microdopamine and produces a micro-amount of anxiety. So an entire kind of, form of micro-attention management is embedded in the way this information slowly unfolds in real time. There's also a type of, the structure sort of implicitly equates algorithmic visualization with insight, and I think immediacy with a kind of form of truthfulness. The second example is Humanity, and it's a video game by THA and Enhance. And you can see here that in the trailer, it shows massive crowds of digital humans surging through abstract urban environments, pressing, pushing, and colliding into each other. And this video shows sort of footage captured from the in-game engine renderer using agent-based, what's called agent-based modeling, and it's running in the Unity gaming engine. These virtual humans are not scripted characters. They follow local rules that generate emergent crowd behaviors, rendered here at 60 frames per second real time. And within this, no two simulations are identical. This form of computation is not about representing a specific person in detail, but it's about modeling behavioral probability at scale and making legible the aggregate tendencies of populations under constraint. The third simulation comes from Replica, an urban planning platform spun out of Sidewalk Labs, a subsidiary of Alphabet Google that has since disbanded. The software produces what they call synthetic populations, modeled on geospatial data, census records, and behavioral proxies gathered from a small subset of actual individual humans. This data is then subjected to machine learning and AI generative systems and techniques to infer entire city-scale populations by extrapolating these partial data sets into decision-making matrices. These abstract personas, as they call it, are then matched to virtual agents who navigate digital models of cities, moving from home to work to school to retail using different transport modes. The resulting simulations are delivered through a stripped-down mapping interface designed for planners and municipal clients. Unlike Humanity's stylized swarm or the New York Times flowing dots, Replica's virtual humans are invisible. They exist as behavioral abstractions, calibrated to statistical norms deployed to optimize transit routes or forecast zoning impacts. They don't appear on screen as individuals. They function as algorithmic composites of city life. These three simulations represent the convergence of two genealogies of artificial intelligence modeling. The first is statistical modeling based on historical data. As in the New York Times example, I record actual humans moving in space, and then I do something with that data set. So a large amount of surveillance that then gets visualized or turned into pattern recognition or turned into predictive models. The second genealogy is the translation of theoretical claims about human behavior, such as in the agent-based modeling example, or behavioral economics or cognitive rule-based systems, into computational models. I think humans behave like this in space. Humans make decisions based on X, Y, Z, and this is my theory of intelligence. It's kind of an expert's theory of intelligence. I'm now going to translate this theory into a computational model. Replica combines both of these historically distinct genealogies into its platform. They're using actual data about how real humans live to drive their theoretical models of their sort of virtue humans. And then the results of these are used by urban planners to shape urban environments. So this kind of convergence of statistical and theoretical forms of intelligence, something I'm interested in. It's sort of opening up this like bizarre hybrid forms of collection and theorization and all forms of sort of applications to how that gets deployed to shape the real world. And so this convergence signals a broader epistemic shift from modeling cities as physical environments to modeling them as systems of flows, of mobility, of demand, of risk, of behavior and data. It also signals a proliferation of intelligence modeling, where expert systems, service bus, massive warehouses of surveillance data on consumer tastes and histories augment generative AI models, and they're all vying for market domination and for profitability. Okay, so to examine this further, I want to just return to a key episode in the history of real-time, which is not this episode, but in 2019, I received a grant, which is a historic event, but that's not the historic event I'm talking about. And so in 2019, I received $50,000, which at the time was pretty good, from a mega grant from Epic Games, and I wrote 500 words. It was the least amount of work for the most amount of money I've ever received for research. It was a good time. To develop new architecture tools and curriculum using their Unreal gaming engine. This followed 5 years of work that I was doing exploring how gaming engines, immersive media, and responsive environments were sort of changing architecture, and it sort of produced a series of different exhibitions and projects like this, and this collaboration at MoCAD with Mitch McEwen, and a whole bunch of sort of pedagogical work around sort of modeling cities in real time in gaming engines and producing predictive sort of models. And so the Mega Grant program was launched with $100 million in funding to support, quote, creative, noteworthy, and innovative projects using Unreal. At the time, Epic was positioning Unreal, shown here in its version 4, the version that was around when they first launched it, as a revolutionary real-time rendering platform. And I quote here, Unreal Engine is the world's most open and advanced real-time 3D creation tool. And so Epic was also sort of ushering in this real-time future and this real-time imaginary, telling everyone to catch up with this new sort of paradigm that was going to change the architecture, engineering, and construction world. And they were sort of, contrasting, traditional offline renderers like V-Ray, shown here, which now nobody even knows what this is, right? And with their kind of real-time platform. And so their aim was to try to saturate architectural and urban practice with immersive, high-resolution, low-latency media environments. So rather than producing a dead asset, an image, we will produce a live asset, a 3D world that you could extract whatever you want from it. What drew my attention and what I did with the grant was I took Epic's money and I kind of built a critical history around the term real-time. And I used their tool to build that history. And so I was really sort of drawn to Epic's emphasis of this term, real-time. And for me, this was not simply just a marketing pitch because it invoked a deeper computational genealogy. And so the concept of real-time originates here with the semi-automatic ground environment, also known as SAGE, which I'll return to in detail later, a Cold War air defense system built on massive mainframe computers, radar arrays, and communication networks, all of which kind of, were sort of located all across the North American territory. As historian Paul Edwards from Alma Mater from Michigan at the time, when he wrote that book almost, has shown real-time computing was developed to serve centralized military command and control systems over vast territories. So he was interested in how the Cold War dynamics of superpower sort of competition and defense shaped the invention of the computer that we use. And these origins shape not only the architecture of computers, but also the metrics of performance, control, and decision-making persist in contemporary systems. So what you're seeing here on the screen is what's called the blue worm, and this is the control room. So all of that physical infrastructure that we saw that was basically tracking airplanes over North America would produce something like this, a kind of a predictive trajectory of how airplanes were going to move over the sort of territory. So we would record, we would first track planes coming in, we would build a history of their trajectory, and based on that history, we would make predictions about their future trajectories. So in order to produce that image, all of that infrastructure had to be sort of built, and the computer that we use now, the real-time computer, was invented. And so I kind of, through this early project, I was asking myself what it meant that architecture's design tools and productivity standards were shaped and structured by this military computational logic. You've probably heard in Design Studio for the students, like to make your projects adaptive or modular or flexible. These are all logistical, computational, military terms and objectives. So actually, like the values of our design systems are kind of structured upon this history. And so today, the push toward a real-time future is driven by the convergence of AI technologies across military, media, that one always does its own skipping, and entertainment domains, and I always forget to change it, and which have all been targeting the city as their new frontier. And so new forms of urban infrastructure is being built to facilitate this, from data centers, from control rooms, from sensor towers, and they're sort of coupled with new computational technologies, such as what you're seeing here, kind of a catalog we produced in the lab of all the digital twins of cities that have been sort of put around. And so together they comprise what I call real-time urbanism, a condition in which telecommunication systems, spatial computing, and immersive modeling merge to govern the contemporary city. Real-time urbanism manages urban life through anticipatory regimes grounded in risk and the foreclosure of urban uncertainty. It's sort of driven by instruments, records, and methods that are constantly obfuscated and invisible to us. And I'm always asking myself, what infrastructures make these predictions operational, and what happens when the logic of simulation becomes the logic of urban management? These models also are underpinned by systems that are built on abstract theories of individual and collective decision making. So all of those expert systems where we think human beings behave like this, or we think based on the way you look, it tells us something about your character, or it tells us something about your emotional state. These have long sort of social belief ordering systems that are very sorted in terms of their origins and in terms of their sort of scientific caliber. And so these theories are rooted in historically contingent and ideologically charged systems of social ordering. And so this is something I'm looking at in my book. Should we look at it a little bit? That's half an hour. Okay, that's a good setup. So I'm just going to kind of, if this is the way I've been thinking about it through my practice and design, I'm going to just survey a little bit, a preview of the book that's in progress right now. And so I mentioned it has a few names, so please help me. The first contender is called Real Time, the Imperial Architecture of Now. Pretty snappy, like not bad. But then maybe we need to put urbanism in there, right? But then we have urbanism and architecture. Is that too much? And then obviously for the peer review proposal that's going out now, this is the title, Real-Time Computing North American and Southwest Asian Urbanism, 1858 to now. The most descriptive, but not the punchiest. And so this is being considered right now by MIT Press for publication in their new PRISM series that is looking at war and the humanities. and I'm madly finishing it as we speak. And so the book is an episodic media archaeology. In a sense, it's trying to build a history between these two images that you see up here. In the sort of turn of the century, 1900, when a telegraph is built in Iran to connect London to Calcutta via the Middle East. And probably, one of many images I could have sort of got for us, an image that represents the real-time city, right? And so as I've been sort of tracing the origins of a lot of the technologies we have, it kept taking me to, those technologies being deployed in Southwest Asia, and those technologies kind of being sort of part of longer histories of information classification, of population management through communication and proto-computational systems. And so in a sense, the book is, it's not so much sort of the colonial boomerang of looking at how technologies of warfare on the edge of empire militarized cities within the center of the metropole. It's looking at how empire and metropole and periphery are kind of being co-produced together through sort of this longer history of territorial management through real time. And so it kind of, begins with this conventional story of the semi-ground environment where we just left off, and with the seminal account of the invention of the real-time computer. In this survey of early real-time systems, LaPlante, Rose, and Gracia Watson write, quote, "A real-time system is one whose logical correctness depends on the correctness of its output as well as their timeliness." A 1958 definition describes real-time systems as a computer that is integral to a physical control system, requiring that output keep pace with environmental change. Early real-time systems, such as Whirlwind and Sage, shown here, were developed to detect and respond to aerial threats by linking sensors, computation, and different physical infrastructures. Another historian, Robert Hitt, described this as paralleling data processing with a physical process, producing results immediately useful to ongoing operations. Historian David Greer notes that this approach redefined the computer from a high-speed calculator into a continuous interactive system, structured around event detection, temporal constraint, and response. He further argues that systems like Sage prompted a shift in how engineers and researchers conceptualize computing, from batch processing to real-time interactivity. So from the automator that you would sort of set off at night that would get through a whole bunch of tasks and calculate and compute things, to something that you would actually interact with in real time. That's the shift, right? And that thing that you're interacting with in real time was also managing and controlling a physical process in real time. And so this ever-present intellectual collaborator that kind of gets birthed at this moment and changes the computer from a calculator into an intellectual collaborator, leads to, I think we know where it all leads, to that ever-present, what can I help you with, ask me anything moment, where we have constant responses from, information at our fingertips. It also produces different forms of real-time environments. These early definitions crystallize real-time as a method of environmental governance. The digital computer, its architectures, protocols, and operative logics was invented to serve the function of controlling environments. The sensing infrastructures that now manage buildings and cities, the design doctrines of modularity and optimization, and the epistemologies of architectural computation all emerged from this lineage. Real-time was not a later application of computing to the built environment. It was the very reason the computer was built in the first place. Real-time emerged through infrastructures built to govern space via signal. Andrea Miller invites us to expand how we historicize algorithmic governance by tracing its origins through what she terms protocological practices of sorting, classification, and imperial control. So not only as a digital phenomena, but as part of a longer infrastructural and colonial formation. This framing has been really sort of instrumental to my project as I've tried to sort of tease out the origins of some of the urban technology we have today. And so as I've kind of looked into the histories of new technologies is like the digital twin that I'm showing an example of here. I've traced it and argue in the book that this 1980s, 1990s DARPA sponsored project, which is called Simulated Networking or SimNet, is really the military origin of the sort of idea and the technologies of this digital twin concept that we're all using now. And it's kind of vividly captured in this illustration in this 1978 white paper, where we see a sort of an enemy aggression event happening, and it's detected by physical sensors in the top left. A set of military planners visualize this in what they call the holographic sand table on the top right. Then they rehearse and plan their response in flight simulators, and then they watch that action sort of being deployed in the physical space in real time. We all kind of understand this architecture, right? We kind of recognize it and so this is the moment where environments are kind of starting to produce these ideas. SimNet would later go on, as I kind of kept teasing this idea, then SimNet kind of gets developed here, then it gets test-bedded in Iraq during the first Gulf War. It creates mobile electronic battlefields. It's actually a simulated networking technology that gets used to recreate historic battles. They go collect all these forensic investigations, so that relationship between historical event, future predictions, and sort of multiplayer liveness is all kind of getting unpacked and invented in this moment. And SimNet would then go on to inform, many of the massive open world architecture systems that we recognize and know today, from the Internet of Things to multiplayer gaming to digital twins of cities. And so as I kept finding examples like this, it forced me to kind of think about the longer histories of the practices that inform these sets of technologies. And so kind of led me to archival documents like this. A telegraph resistance graph from 1860 that was connected in the Red Sea for a line that ran from London through to Calcutta. And I kind of realized, these real-time histories where Southwest Asia and North America kept reappearing as twin vectors of technology and computing development. And so I kind of started to try to, think through if in the semi-automatic ground environment, that worm, the worm sort of image that I showed you in the control room, what were the spaces of governance in the 19th century, and where were the spaces where sort of documents like these were received? What was the sort of assemblage of infrastructures? If in the semi-automatic ground environment, a network of data center servers produce an image of the territory like the map we saw here, cable sort of sectional details, the laying of underground cables in the Red Sea, telegraph architectures, and all sorts of new sort of networks that are produced also create an image of the territory in some other way. And so this is the first moment where signals and signals are kind of being brought together to manage territories and populations from afar. Southwest Asia would become, I think, in my book and in this history, would become a recurrent testbed for these systems, and later a front line in the development of real-time computation. First under European empires, then under the US-led world system. It shares this condition with North America. Together, they form the operational corridor through which real-time systems are circulating. And so these two geographies, linked not by culture, but by architectures of empire, define the coordinates of my book. And today, this wiring of empire, computation, and geography manifests across multiple domains, most visibly in military systems, but also in entertainment media and in urban management, all shaped by the same real-time architectures. And so part of the book is looking at how environments have come under forms of communication and computational control. I'm also interested in how humans have come under different forms of modeling in real time. And so I kind of remember when the metaverse was being launched. What was that, like 2020? That wasn't that long ago, right? Remember when that was the next thing? So this is, this is like a kind of like a little bit of a preamble into that moment. And it looks at this sort of paradigm of virtual human, real-time virtual humans. So 3D humans that talk to you in real time. And they're kind of fascinating because, in that explicit model of intelligence that I sort of, was sort of mapping out for you, they're humans that have to, they have cognitive models, they have perception models, they have emotional models, and they're also also being used by, in this case, the Institute for Creative Technologies, a USC center in California, to model virtual Iraqis, like this one shown here, Amani, to be used for what they term tactical training competency. So, teaching soldiers how to talk to a woman in a hijab in order to be able to extract intelligence of military value. And so part of the whole purpose of the modeling is not so much what Amani says, but to sort of acclimate soldiers to going into a domestic space and interrogating a virtual human like her. These virtual humans later get inserted in, scenographic mock-ups like this that are just like hilarious in some ways and like so kind of architectural. And USC is, because the ICT is in Hollywood, is in Los Angeles, it was actually set up to leverage Hollywood special effects with scientific research. So there's this kind of collapsing of entertainment technologies with military training, and they're kind of feeding each other. And they're sort of, being used in the first Gulf War. They get later, first they're used to train soldiers to go to Iraq, then they're used later as virtual therapy humans to sort of care for humans after they come back. Harun Faruqi, the German filmmaker, has famously made a really beautiful set of films that sort of tracks that whole journey. So how these technologies kind of first get used for training, then later get deployed for care, and also all these virtual humans are now in the AI sort of chatbots that we're using. But it's interesting because for a while, three-dimensional real-time and these explicit sort of models, that was sort of the, that was the state of the arts for what intelligence looked like, right? Like we needed to see a realistic 3D human talking to us in real time, and that's how we knew that computer was smart, right? That was the model. But now, that's sort of been dissolved. Everyone realized we just need a blinking cursor that's on that talks back to you. So this little shift from, the metaverse and immersive real time and immersive intelligence to this statistical one is a kind of an interesting shift. And so in the book, I think we all think about this as scholars. The archives of military violence are vast, and there's so much under-examined in there. And so as I'm looking at this, I'm also trying to find sort of ways out from the sheer horrors of real time. Pardon me. And so I don't know if this is the right way to do it, but if the USC is sort of launching a certain model of what a virtual human should be through their sort of, through Amani. I'm trying to sort of ask what were actual Iraqis at the time thinking about and talking. And if the USC is a type of institution that was set up to bring artistic and technology, artistic practice and technology together to produce creative work, I look at this group here, Seda, that was operating between Baghdad and the US during the same era, and they were sort of leveraging resources in the global north to give training to Iraqi youth who wanted to be artists. And so through Seda's work and through workshops that they were sort of co-running using mixed reality architecture, there was, basically a laptop and a Skype, running together in parallel. I look at these alternative models of what a virtual human might look like. And so we might look at this, a setup like this on the left, two tables connected together 7,000 miles apart through Skype, and we might not think that this is maybe the most innovative model of virtual human architecture we've ever seen. This is a mixed reality architecture in the same way that this is a mixed reality architecture, but this one has been invented and innovated and looked really, really slick in real time for the purposes of violence and domination, whereas this one is actual Iraqis undergoing that process, trying to sort of make artistic work as a form of resistance in that moment. So, there's moments in the project that as I'm sort of charting the imperial origins of real-time, I'm trying to offer a counter-computational project that maybe isn't necessarily about digital computation, but those building blocks, like how do we think about transmission rather than connecting networks for reasons of domination, if we connect networks for reasons of solidarity? What are alternative models of humanity outside of these belief systems that are encoded in tactical training archetypes? Does that make sense? So that's kind of some of the things that the book's trying to do and navigate. Okay, we're doing good for time. So in the 15 minutes I have left, I want to just show you a few projects from my design practice that are sort of, scalar interventions in real time. So how I'm sort of teasing these things out. Does that seem okay? Yeah? Okay. And so my intervention is to connect these histories to contemporary design practice, to try to offer a critical computational counter project to real time, to use these tools to talk about those histories, to subvert them, to also, so not just critique, but to, try to think about alternative design methods that render these systems visible, material, and open to transformation. And so I'm just going to show 3 projects to think about this at 3 different scales: at the scale of a document, at the scale of the city, and the scale of a house. The first project, and in my design practice, most of my projects are collaborative. I'm always working with other people. This project's with Felicity Scott and Mark Wasuda for the Sharjah Architecture Triennale. And it's a project where we revisited a 1975 film archive that was developed in the lead up to the 1976 UN conference on human settlement habitat. Sorry, I've just lost my brain a little. So the film archive, in revisiting this film archive and participating nations in the lead up to this conference on what human settlement looked like, nations were asked to basically make a film that narrated what modernization looked like in their countries. And as we looked at this film archive, it became really clear to us that there was these like repeating motifs. Like, every film started with like a chicken, and then that chicken would be sort of a signal, would be a sign of rural life. And then it would sort of transition from a chicken and, manual labor to a crescendoing new city with industrial automated forms of labor that would then produce, show new subjects of the state that were being educated by new experts from overseas. So all of these kind of, different films in some way were narrating a similar type of what modern development looked like. And as we looked at this archive, the way we chose to present it in this exhibition was to extract, 10,000 or so clips of something that we then categorize as tropes of developmentalism. So you would come into the exhibition, you'd press a button that would say chickens, and it would show you every chicken from every country in the world. So I could tell you that the United States was a kind of global controller of narratives around development, or I could display that to you in real time. And so in order to make that sort of instant sort of moment of discursive and immersive impact, we built this, real-time video playback system with 160 monitors connected by 80 Raspberry Pis and Arduinos. We encased them in custom metal. All of this was to sort of take the logics and the arguments that we were seeing embedded in the archive and our claims around that history, and to make that visible to you in real time. Another project, Control Syntax, also co-authored with Mark Wasuda, and an ongoing, I guess, over a decade project now that looks at the global smart city movement. This is Mark and I clearly entering the eco-zone in Songdo, a smart city. And this project started, I think before we had this moment where generative AI and simulation models are hitting the city. Maybe the most impactful movement that brought technology and cities together was the global smart city movement, right? And the smart city at the time was always being presented to us through diagrams like this, right? Like abstract models where apps just frictionlessly descended down onto the city, and everything was updated and everything ran really smoothly. So part of the project was to try to basically map a cartography of the smart city as embedded within its rhetoric and within its material reality. So we're really interested in sensors. We ask really silly, simple questions. How has the city physically changed because of smart discourses? And often it changes by you put sensors here, you put a control room here, you build a data center there, and then all of this has massive consequences. So we were really interested in these technical infrastructures. We were also interested in the types of narratives those infrastructures were building. Narratives built on risk and on this kind of attempt to control away urbanity in some way. That all of these systems were kind of disaster detection systems in some way redeployed on urban systems. And so it's 2 exhibitions that look at 2 smart cities. Control Syntax Rio looks at a smart city in Rio. It starts by examining, urban control rooms like this, the Center for Operations in Rio that was built in 2016 in the lead up, 2014, sorry, in the lead up to the 2016 Summer Olympic Games. And The exhibition traces a route from Copacabana in the bottom right to Maracanã Stadium in the top left, and these were both sites of the Olympic Games. And so there's a model in the exhibition that traces that route. Core was built after kind of disasters like this landslide, and in the lead up to the Olympics, the city of Rio basically had to assure its international partners that it was able to manage its city. And so, different forms of urban crises, from exploding buses to urban crowds to traffic to security, kind of all came under this form of computational management. The technical and conceptual armature for Core originated in IBM's Smarter Cities initiative. And this is some photos of it at the Het Nooy Institute in Rotterdam. And you can see the model in the front and sort of some of those videos I was showing before. And so Core, the Center of Operations' primary task is to monitor, assess, and represent the metabolism of the city and to respond to actual... I'm getting vibes from your dog. Okay. It's good. We've got 8 minutes left. And so the metabolism is to respond to actual or potential interruptions to drain, slow, or block it. Core determines if Rio's metabolism is normal or abnormal. Through the logic of the IBM code around which it is built, Core measures abnormality according to 4 escalating scales of intensity, from incident, event, emergency to crisis. How this scale is registered and represented and how it determines response form the foundations of Rio's control syntax. Overlaid on the traffic route, our project control syntax Rio also traces a decision path through Core's algorithmic decision-making matrix. And so the model aligns the material traffic infrastructure of the city with the immaterial syntax of Core's urban management code. It allows us to see the physical city, its traffic apparatus of streets, lights, and sensors organized through Rio's control syntax. At first glance, Core's control syntax appears banal and managerial, yet it is also charged with potential crisis. For example, if protest erupts, then traffic will have to be redirected to avoid paralysis. If buildings explode, routes will need to be cleared to usher response teams. Explosions, fires, protests, landslides, rallies, and sudden tropical storms combined with faulty traffic lights, accidents, spilled trucks, burning buses, and quotidian congestions as elements of the Core control syntax. For both Rio and Songdo, the control limb is the active demonstration of urban intelligence, urban sensing, and information extraction. Titanic walls of data screens and camera films form a sublime image of urban omniscience, a proscenium of management. And so our project kind of looks at how spaces like this are both spaces of representation. It produces an image of the city. It's a PR space, but it's also an operational space. There is real decisions being made about the city. And so all of these different things are kind of being compressed into these spaces. So these moments where all of this real-time data on the city is being shown not for computers to talk to computers, but for human decision makers, these are, I think, the most consequential moments and most spaces that we should pay attention to. It's also a product of this longer history in what we term computational urbanism that I've been sort of tracing. Okay. So the second project's easy. I can just press play. Hopefully the sound works. It's called My Domestic Routines, and it's actually the project I made for the Architecture League prize when I won it. And so for 5 weeks, I equipped my home with smart products that I purchased from IKEA, Amazon, Google, and Wise. And using that data, I crafted a digital twin of my own home and avatars of myself, showcasing every potential smart domestic scenario possible. It was pretty weird for my research assistants that they had to 3D model me and then make me dance and stuff, but we all got through it. We also made a film from the feeds. The film reveals how constant surveillance creates a neurotic domestic subject obsessed with both showcasing and securitizing their life, driven by underlying fears of the American suburban imaginary. We also hacked the proprietary smart home systems and made an alternative, and made an installation that displays a catalog of the smart devices. And a recursive routine connects these proprietary systems and casts them in a never-ending performance of detection and response. So in a way, there's a kind of a narrative, there's a technical breakdown, there's also a sort of virtualization of all the possible smart home typologies. And so this was kind of the first time where I became the subject of my own research. And having like looked at the sort of the violence, the shifting sort of ungraspable kind of, concepts that come out of urban technological discourses, and trying to keep up with the rhetoric and trying to do spatial analysis to find out what actual reality looks like, in that asymmetrical relationship between us and these massive sort of monopolies. At some point, there's no new insight about their sort of logics. We understand we live in a surveillance sort of capitalist system. We understand that they're built on these longer imperialisms, and it's very important to continue to do that research and to be very sort of rigorous about exactly what they're doing. But I also think maybe one tool we have as creative practitioners is to launch these personal stories, to actually see how, we are experts in our own subjectivity and in our own lives, and to sort of, trace my own history through these technologies, add something to the mix, and maybe has a certain impact, and maybe some of those other more didactic forms don't. And so I've been thinking about these things also in some of my teaching, and there's been lots of sort of interdisciplinary work we've been doing, and we've been sort of taking sort of climate models and all sorts of technical infrastructure. So just, working and designing with these systems kind of continues to drive the way I'm thinking about things, and to sort of build pedagogy that brings a whole bunch of different folks to the table. I find, as being someone who's trained as a designer, is interested in how histories of design and technology inform our built environment. When I sit at the table and give more context to people who are more sort of technical in some way, they really appreciate that. And it's a really kind of amazing conversation that we can have. I also think it's like really, really important to be playful and experimental, and to really sort of let students push the technology in their own ways. And something that I've kind of noticed that's been happening maybe in the last 2-3 years since ChatGPT came onto the market is, thinking through like what does it mean to train skills? What does it mean to cultivate judgment? And how important criticality is in this moment. So it's actually a moment where for me, I'm using AI in all sorts of ways. I'm kind of doing lots of software development with AI. So for me now, times when my project would need a software developer to create a specific tool, I can now create that tool myself. And if we get a sec, I'll show you some of that. And so I have kind of, 30 years of needs that are shaping my requests to these systems. I'm seeing students sort of being very sort of, their judgment is being cultivated through these systems. So I think we're in this moment where we're transitioning, where people who have really urgent sort of requirements are just accelerating with these tools. But people coming up within these tools are kind of going to have a very sort of monopolizing singular sort of framework of the world. So I think we have to sort of rethink what it means to depart skills, because right now in my Core 2 class, where basically all the students are doing AI coding, and we sort of are pushing concepts first, and then they're making their own software as they need to. So software development is now kind of accessible, for better or worse. So we might not need to push certain things in the same way we did. That said, like the need to kind of create hardcore 3D sort of expertise to figure out how to bring things into physical reality, these are things that might not be as ever present and as easy as a quick response from an AI system. So there's some huge amounts of acceleration that are happening. There's also huge amounts of, apathy and alienation from our labor that's also happening. Students report to me in this studio that they're feeling less like they own their work, right? And they're feeling sort of slightly, so how do you sort of navigate that? And so as we've been kind of like now just developing software, and it's like shifted the way I teach. we're not sort of giving the students a program, a site, and then like a method. We're asking them to develop a critical project that leads them to the site. Then they invent a brief for that. Then finally, they go and make their own tool to implement that. So it's a kind of a incredible sort of shifting, and we don't have to be led by our tools as much. And in the sort of few minutes I have left, I just wanted to show some of this like different software I've been making with AI, from real-time systems like this that sort of exposes how a lot of these sort of face tracking models are working, to this exhibition that's actually going to open at the CCA at the end of this month. And this is for Ishan. It's a 36-channel video installation, and so we've kind of developed a whole system to take a film archive. That process that I showed you for the media habitat that we did sort of humans did it. A lot of it has now been automated, and this whole like video playback software that you're seeing here, that's extracting the clips, that's building sort of playlists, that's playing it back in 36 channels in real time. All of that is something that I've kind of coded as my concept around the sort of project has developed. So in some ways, I'm kind of, it's terrible software development, but it's a sort of explorative, creative use of AI coding. So I think like that's where I see it like a lot of kind of impact for our field, rather than, not just sort of in real estate sort of speculative sort of renderings, and not just in sort of how we sort of turn images into sort of 3D, which are kind of like incredible, but also just we can now create so many of our own ecosystems and workflows. In the -2 minutes I have left, and to kind of summarize and conclude. Okay, so I hope I have shown today that AI and architecture refers to spatial and material systems, and that they are sort of part of this sort of drive towards a real-time sort of urban future. And that AI systems perform tasks traditionally require human intelligence, such as learning, reasoning, and decision-making. And that this history is rooted in mid-20th century ideas of cognition, but also probably longer histories. I hope that I've shown that these systems are built on data sets and histories that often go unexamined. And through my work, that I'm interested in interrogating how these archives are produced, whose experiences they encode, and what biases they perpetuate. These systems also operate within regimes of smartness, a combination of what I've termed statistical optimization and immersion. They produce live computational events based on how environments, populations, and individual humans are modeled. And through my work, I try to critique this tension and reimagine these technologies' role in design and governance. They also have a representational history, and I hope I've shown through my work how I'm tracing how computation from early automata to post-war informational urbanism have shaped spatial representations and also reinforced colonial systems of control. Thank you very much. Oh yeah, questions? Adam Fury in the front.
That was amazing, thank you. I have two questions. You can answer one, both, or one is on aesthetics, like this, specifically the aesthetics of the installations.
This is a nice, this is a real-time app. Is that good? Do you like that one? Or is that more your vibe? Okay.
With the exhibitions, so the book you say like you're interested in counter narratives for the technology, so one that's about control and about solidarity. I'm wondering about like the aesthetics of the exhibition. It seems like you're invested in like reinstituting the aesthetics of like control rooms. There's always like monitors, there's always a box, there's always like a subject in the middle, surveying objects in front of them, and like imagery. They're literally in control of the imagery that's coming out of the box. So I'm curious about that move. I would imagine that there's, like if there's a reason behind it. The second one is about, the second question is about error.
About, sorry?
Error, like data being bad or something. I remember last summer Sarah Sharma was giving a talk for the Course Institute summer workshop, and she was talking about Gen AI as like a bad intern, like a gendered male, like a shitty intern, like a guy who makes up like 40% of what he's telling you is often wrong, and like somehow we treat it as if this like bundle of facts, good advice, and we just have this sort of tolerance for it. That's maybe what it is right now, but it's still like wrong all the time. So I'm just curious about like how, like yeah, you have a theory of like error, systems that not really working how they're intended, but the architecture of how they work because of that.
Yeah. Excellent questions. To tackle the first one, yeah, I totally agree. So I think, in the longer practice projects talk, I sort of, looking back, reflect on my projects, and I think there's like maybe 3 strategies that I've developed. One is the rendering visible, which I think we can see in some of the work I showed today. So what are these logics? What are their histories? Where are these invisible systems? And so part of that is didactic, part of that is a theoretical claim, right? Like it's not saying that it's making a claim about an emerging urban form that I'm producing a kind of inventing a model of. And so I want you to go in there and, none of the exhibitions have something you have to read for a long time. So I want you to occupy the aesthetics of that research. So definitely performing the logics of the material on you is part of that, for better or worse. Maybe it's alarming, maybe it's seductive, maybe it tells you something about how your visual attention is being trained to be hypnotized by these things, or maybe that's a intention in that one. Some of the other projects are thinking through, as you've said, counter models. Is there an alternative? And so with the real-time one, it's not less, is there an alternative to real-time? It's what are its building blocks? What's being hoovered into it? What are the targets? What are the vulnerable populations? And how do we what do they want? And what if we break down computation into, a symposium that I organized a few years ago around this was around liveness and transmission and what was the last one? I can't remember right now. But part of that was to bring a whole bunch of folks who work on those ideas that aren't necessarily thinking through real-time computation. So how are historians thinking about transmission? What is another form of information channeling that isn't through our ideas of the computer as the only sort of subject and the only thing through which we know the world? So part of it is, those counter models isn't just can we have a counter computational model, is can we build a counter worldview? And it's piecemeal, but they're trying to sketch those out. And then one of the other strategies is, and through my domestic routines where I'm the subject and object, a fictional narrativized version of me, but a version of me is, an important part of that project that I didn't get a chance to speak to is I'm looking at 2 scales of technology that order movement. One is through smart home technologies in your house. The other one is through migration. So I kind of narrate my own story as a migrant from Iran to Australia to upstate New York, and what were the systems of governance that allowed me to migrate and my family, and this moment when the white Australia policy sort of shifts and it allows my family to migrate in the 90s. And so if that is a kind of a global movement, I sort of look at local movement in the house. So, these things, they don't come together naturally, so they have to narratize them together, but I'm kind of showing how technologies at different scales channel movement in some way. So those are sort of some of the different ways I've been thinking about it, because it's a totalizing asymmetrical relationship to this kind of these systems. But I think importantly, sometimes we oversubscribe totalizing power to it because the rhetoric is so strong, and when you go kind of look at it, it's patchy, it's ad hoc, it's not doing what it says, they're all bad sort of concept art pieces, so I think we have to poke fun at it, but we have to also, part of what I'm trying to say is that this is what is seducing our entire society, right? All of our sort of smartest people in the world are doing this, and it's told to us that it's the most globally transformative X thing happening right now. So we can ask it, is it solving some of our global issues? And so our global issues is climatic, it's militaristic, it's about inequality, right? So are these issues being solved through these systems, or are they kind of being said that they can augment? And so, many of these systems set out to solve the problems of their own survivability. Hey.
Okay.
Oh my God. Yeah. I'm just going to say two analogies. So a really good friend of mine who has a huge office, and is like doing, competing with OMA scale office. They can't get anyone to build their projects right now because of three things. There's no materials because of production supply chain, as well as the tariffs that have come in. There's no labor because of the terrorizing of informal migrant labor that are kind of present in construction industry. And what little capacity is left in the construction industry is currently building data centers for AI. So we've gone from building luxury housing as a kind of a real estate investment that almost held maybe a few humans, like once every 3 days, once 3 days a year or something, to just not at all. And so that's where, so that same colleague, friend, also says that basically they're getting emails from all their clients. They're getting AI to put it into bullet points. They're writing bullet points, and then the AI is taking those bullet points and composing an email. So actually, it's not doing anything other than performing professionalism in that moment, right? So the core kind of communication, if we all sort of put away with certain norms and manners and pretending like we've got a kind of a professional, these are the sort of two scales where I'm seeing it have huge amounts of transformation in practice, let's say. So the error one is kind of, maybe the most consequential error it's having in our field is depleting all resources, this huge structural sort of depletion. But it is kind of what it's useful for is to make it look like a human hasn't made an error in these low level things. I will say it's getting really, really good. It's gotten really the kind of, from a software coding, I've been using it nonstop since day one, and each week a new kind of whatever comes out. When I talk to my friends in consultancy, do you follow the /consultant thread on Reddit? It's hilarious. All the consultants are lamenting the fact that they advised all their clients to get rid of their labor force and implement AI systems, and now those clients are firing them because they realize they can get strategic advice from AI. So that's what's happening at the low level. Then at the high level, basically a bunch of the consultants like McKinsey hedged the firm that's taking over is Palantir, because they're embedding sort of frontline technology experts into companies, and they're sort of taking all of that company's data into their Palantir systems and giving them insights. And a lot of the consultants hedged that clients wouldn't want to share their proprietary data. They've hedged wrong. So many of the traditional consultancies are trying to catch up. So I'm it's a long way to say we thought no one would want to share their data, but this convenience and whatever it is, the drive to sort of, the bottom is pulling it up. My friend in advertising, though, who's a creative advisor, he's saying it's a moment where for them, they're leaning in and they're saying ideas cost more. So there's definitely a whole bunch of people in that field that are trying to drive down costs through AI. There's a whole bunch of people saying now that unique human creation is so novel, that costs more. So I didn't answer the error question, but I'm kind of saying the technology is getting better and better. It definitely was that, but it's also being used to do really menial things that are more about performing professionalism. It's depleting all of our resources to actually build anything, and maybe ideas cost more now. Do you want this one now? Wait.
Maybe I'm gonna maybe I'll connect error and a question that I had around notions of safety and security. So maybe example one would be, it's no longer active, but there used to be a suite of apps that you could install on your phone that were essentially tracker apps for locating convicted sex offenders in your area. And the visual tropes they used were some combination of like military bullseyes and targets, right? But also combined with what we associate the real-time mapping of GPS geolocation. But in fact, the locations of sex offenders were based on the SORNA database, which is, to Adam's point, totally erroneous, like rife with errors, different state to state about what the requirements are for when offenders have to register and how up-to-date the information is. But the only thing that's actually tracking real-time is your location, right? And everything else is an illusion. But what I'm interested in about that interface is the way in which it positions the public sphere as being a very scary and unsafe place for us. When statistically we know that most sexual abuse actually occurs in domestic spaces by somebody that we know. That was example one. Example two is, did you watch the Super Bowl?
What's the Super Bowl?
Okay, good. But Ring Doorbell had an ad for a new feature called Search Party, where you have to opt out of it. But if you don't opt out, it scans your doorbell footage for anyone who's reported a lost dog. And then if an image of their lost dog appears on your doorbell footage, then that gets aggregated and supposedly they can help you find your lost dog. Which I thought was really interesting because they have also been wrapped up in a controversy around contracting with law safety that uses like AI-enabled facial recognition software for law enforcement, and the whole controversy around whether your doorbell footage is contributed or like being used by law enforcement for policing, right? So, but again, like the Ring doorbell already also positions the public space as being a dangerous one, right? And the perimeter of your home being a kind of boundary between safety and danger. And then so much of what you're talking about in terms of the control center in Rio is also one which is meant to make us safer in the city, but is actually attuning us to a myriad of disasters. I mean, you have this amazing catalog of horrible things that could go wrong at any moment, right? That we are now like poised to respond to and protect ourselves from. So, I don't know. I think my question for you, I guess, would be: I think you talked quite a bit about the way that risk drives the narratives around risk and rhetoric of risk drives these systems. It seems like there's also something at play in which, maybe unintentionally, but as a byproduct, we are made to feel that we are under ever-present imminent danger in order to convince us to kind of buy into these systems as a way to protect ourselves. But the systems they're not really making us
Yeah.
safer. Like, is the smart city statistically safer than the dumb city?
Yeah, it's amazing, like examples, and remind me again. Some of them will go into the intro of the book. But yeah, I love it. Yeah, I agree. Like, I think it's alarming, right? Like look how beautiful this is. Nothing's happening, but it's just moving all the time, right? Like, and it's moving with like a little bit of delay. And so whether I make that super nice with like the loop and tune it to be slow, or whether I make it slightly alarming by tuning it to be quick, that's like one threshold of value difference, right? So absolutely, as we know, the history of advertising and marketing has told us that making people anxious and nervous and insecure is going to be one great psychological tactic towards selling them something. And so part of that securitization and the sort of performative securitization, it's not just happening within sort of the consumer marketplace. We saw it after 9/11 in the United States where, every time we go through an airport now, we are performing, right, security. And there is so much sort of biometric capture, and there's no evidence-based kind of research on the efficacy of that to make us actually more secure. But definitely produced a kind of a new marketplace to sell some sort of military technologies in a civilian sort of sphere. So absolutely, like there's a political economy around these, and there's a kind of a, if we know the military industrial complex, I was charting something around the military entertainment urban complex. So yeah, the techniques are built on visual management. They're It definitely like real-time monitoring. Like when I installed all those cameras in my house, I was just like watching the most banal crap about my life. And it was like so engrossing. So it kind of doesn't just produce a neurotic subject. It's sort of, like it produces like the neurosis is both anxiety and self-absorbed. And I think that's like very helpful as a kind of atomizing of society to then, do all sorts of like, we understand what that's going to build, right? So I think there's a long history of military tech coming into consumer grade context, and there's a kind of multiple scales of performative security. So trying to make evidence around this is always tricky, but that's what at least I'm trying to make spatial evidence around some of these things. Like just what is the length of capture? A lot of those, the project in Greece that was looking at the sort of smart technologies that were installed on the EU border was trying to understand their zone of detection, was trying to understand who moves through them, was trying to understand their technical capacities. Was there a question up there? No. Yes.
Thanks, Farzin, for that, and also for reserving that special slide at the end.
I actually put that in after I saw you today. I'm like, all right, I need to.
Yeah, I thought so. I was curious about a couple of things. I think like feel free to answer this however you want. I think a lot of your work, what it does so well is it's taking these like marketing terms of like smartness and intelligence and showing how these systems are maybe not so smart or not so intelligent. Through the visualizing, you're actually showcasing how they sort of break sometimes, or even by charting its history, you're showing like how these biases are embedded within these technologies of where they come from and what they become into. And so I'm interested now in like how you spoke about real time and simulation. If real time is this case where you're sort of trying to react to the city as and when things are happening. So something breaks down, you're able to go into that sensor, fix it, and so on. But then within maybe the age of machine learning and how machine learning is going to be fit into these systems, I'm trying to think about how now that changes. Because there's a small, like, I was looking up these self-driving cars and how they are trained. Essentially, a lot of them are trained on simulations that are
synthetic data. Yeah.
Right? They're not trained on actual humans walking on the street. So what people started noticing was that if you actually behave like computer simulated humans, it reacts to you better. And in some ways, you're actually, what that's saying is you have to turn into an NPC for you to be safer in the city now, because these systems could like not read you as a human, because humans are unpredictable in so many ways. It's harder to predict how humans react. So I'm just wondering, now moving forward in real time and as agents in designing these systems, like urbanisms and architecture, where do we stop becoming, like how do we stop becoming these NPCs of like self-fulfilling prophecies of that the data that's collected is reflected back on us through simulation? I don't know if that makes sense.
Yeah, so it's, I don't know, I guess like in the replica example that I was showing, the one that had synthetic population modeling, actual humans do something. Replica sees movement based on a neoliberal worldview. So humans are always going somewhere. There's no humans like walking their dog or like walking without purpose. You're either like at home, at work, shopping, or like eating or other. So within other is all like, is that 2 hours of life you get outside of your full-time job. So, obviously systems built, and the data is coming from point of sale purchases, from credit cards, like maybe it was coming from Google, but they were like trying to say it wasn't. At some point it wasn't anymore, definitely. And then urban planners are kind of using that to make decisions about should I put a bicycle path here or not, right? So urban futures is being shaped by that. Like it's a longer version of the feedback loop you're drawing, right? From being seen by a machine to acting in a way that will be seen by a machine. And so part of it is that, right? Like how are we shaping around the structures and the logics of these models that have, in this case, I think a neoliberal view. Like all movement is purposeful, and so there's no accounting for unpurposeful movement. And if you don't have a digital sort of tracking device, you won't be seen in their models, right? On the other side, do we need to normalize this vast amount of surveillance just to decide where a bicycle path goes? There's like, so this kind of like, that's what I was saying. So like, so computation real time is like the primary, this is both like an ontology and epistemology. It's like what we know and how we know, and it's like flattened onto a glistening screen. And so like this kind of like need culturally for everything to be data driven, right, is kind of like allowing, it's sort of a little bit like what Ali was saying as well, like our homes have to now be like data driven. So there's a kind of larger sort of cultural conditioning of data-driven decision-making and the value of that. And I was trying to tease that out with the New York Times article. So I would say it's like, it's not just about like, do these things do the things they say? Are they smart? Are they stupid? Like, they're very sophisticated technical system. Part of it is, are they distractions? Are they solving the actual urban problems we have? Are they solving the global issues we have? I can't remember my last point. Whatever I was just saying then, what was I saying? Yeah, I lost it. I'm sorry. I lost it. Yeah. Hi.
Right. I was kind of curious about, to follow up on your point on, is it really necessary to have all that data-driven culture, especially with the emphasis on self-driving cars? There's a lot of policy controversy going around too. Around it is the technology seems to be going at a faster pace than the policy can't catch up with it. So I'd be curious on what do you see being the role of this technology in policy and decision making, if there is any role at all, and how do you see do you see a need for policy to catch up on how this technology is being developed?
Yeah, and I want to answer that through a little bit what everyone's saying, which. Be under no illusions, like these things are kind of, they reflect power structures, what happens, right? So it isn't a kind of accident that something comes in. Like I could launch whatever, like we've all probably made an app and realized no one's going to use it, right? Did everyone do one of those projects in early Web 1.0 where you like I spent like 6 months like making an app and it was like really hard technically. And then like I launched it and then like no one used it. And I was like, oh, making it is like not the thing. It's like marketing it and people actually using it, like building an audience. And the only way you like put it down everyone's throat and make it like habituate them to it is through like vast amounts of capital. So whether these technologies are good or bad, whether they're like, there's like really great things you can do with them. I just want to kind of say that, right? So the policy gap and like what's our work, what can we do? These are like different arenas. So in one arena with urban ethnographers and scientists and geographers, there's like a common piece that's saying, okay, like the digital twin concept comes out of military, logistical sort of origins. It sees the city within like a kind of closed sort of, there's sort of closed environments that are highly controllable. The city isn't that, right? Like the basically dream vision of these systems is that you change something in the digital interface of the city and the city changes in real time, right? But only like war can change the physical structure as quickly as the digital, right? You can only destroy as quickly as you sort of press a button. So physical reality can never catch up with that sort of digital sort of desire. But that gap, like that is something, it's a definitional concept that these technologies can never overcome. And it's like a temporal lag, but it doesn't sort of change this like long sort of desire that that's what innovation and futurity looks like. And this is what technical, and to kind of like Adam's point a little bit, there are so many errors, but the seamless way it's responsive sort of occludes that, right? As we know, these are all patchy sort of federations of models, right? And like putting them together with a veneer of, computational fidelity, that they're like 3D, immersive, really responsive. This makes them look like they're sort of, very sort of seamless, even though they're kind of being held together with glue. So I think the policy lag is, it's definitely like, deploy or die, right? Like it's all of the sort of mantras of get it out before be first to market. I kind of want to say a little bit is also that every once in a while, those in power invent a new fiction, and then they have the capacity to reorder the world to that fiction. And and so having looked at sort of technology for so long, I always wonder, do I need to like, am I giving this like, validation by critiquing it? Am I, like, do I have to keep sort of doing the work of playing this kind of catch up with a different person's kind of fiction becoming everybody's reality? So that's what sort of, Mark Zuckerberg tried to do with the metaverse. Like billions of dollars were trying to make that fiction a reality. It just didn't happen because like nobody wanted it, right? And it was this moment where Facebook's stocks were tanking and he had to change the story and he had to keep showing that Facebook could grow, right? Like all of these technology companies are monopolies. They have no more market share left. Like there's no more extraction in sort of social media or advertising. There's nothing left. So they have to keep inventing a sort of a new marketplace so they can continue to be evaluated as a growing sort of, company with growth. So they can continue to keep getting financing, other people's kind of, debt that they can then sort of, create these speculative sort of technologies for us. That doesn't mean there aren't like really amazing people and they're really useful tools and you can do like incredible things with them. But this is what's happening right now. This is like the fastest monopolization and convergence of intelligence through like 5 channels that's happening in our life. And we can all feel how quickly it's like pushing on us. And our job is to make that acceptable, exciting, problematic, so we have to all navigate that. And these are some of the questions that we're sort of talking with my students and we're trying to figure this out. But I think we're all feeling that right now. So yeah, I don't have like the answer, but I would just say it's about power relations and we have none. Thanks.